Welcome to remembrance-kjv.com. This is video number 1. On this channel, we take a look at the academic environment that prevailed during the times when the Bible was first compiled. The purpose is to enable scholars approach scriptures from the same perspective as the original writers of the Word of God, and to put to an end subjective interpretation of the Word of God. By academic environment, we are referring to something quite broad. That's the curriculum. And by curriculum, we mean everything that is learned and taught. In short, we are taking a look at the subjects that were learned and taught during the time when the Bible was first written. But for the meantime, we will devote our attention to the subject of mathematics. It should be realized that for the greater part of the period during which the Bible was first compiled, it is Africa, then identified as Egypt or Abyssinia, that served as the dominant power of the world. Therefore, in taking a look at the mathematics of the Bible, we cannot avoid taking a look at the mathematics of Africa. African mathematics is non-written mathematics, the reason being that it still remains undocumented. It is the kind of mathematics that one would generally refer to as mental arithmetics. Mental arithmetics should therefore be understood as the undocumented mathematics whose algorithms researchers are still struggling to attribute a scientific explanation. The person who brings us back to the mathematics of the old world is the genius arithmetician of Benin, Thomas Fuller. He is also known as Negro Tom and popularly as the Virginia calculator. Thomas Fuller was born in 1710 in some area between Liberia and Benin, the area that I've shown on this map by means of this sort of peach green shade. However, according to this research, it is to some degree correct to assert that Fuller was from Benin, and it is a possible hypothesis that he was a member of the Yoruba people. In 1724, when Fuller was 14, he was kidnapped and shipped to the United States of America, where he was sold to a planter in Alexandria in the state of Virginia. He served as a slave for the rest of his life. But a few years before his death, Fuller became renowned of his gift in mental arithmetics, and his fame spread across the whole of the eastern seaboard of the United States of America. For a proof of his gift in mental arithmetic, I will cite only 4 examples. First, Thomas Fuller was required to find the number of seconds in a year and a half. It took him nearly 2 minutes to arrive at a solution of 47,304,000 seconds. Second, on being asked how many seconds a man has lived whose age is 70 years, 17 days and 12 hours old, Fuller responded in a space of a minute and a half. His result was 2,210,500,800 seconds. Third, it was proposed that, say a farmer has 6 sows and each sow has 6 female pigs the first year, and they all increase in the same proportion to the end of 8 years. How many sows will the farmer then have? This proposition took Fuller nearly 10 minutes to compute, despite being interrupted for several times by his interviewers. His solution was 34,588,806 souls. Fourth, in a separate interview different from the one in which the first 3 propositions were made, Fuller was able to find the product of a 9-digit number multiplied by 9. 4 propositions in which Fuller relied completely on mental arithmetics. No pen, no paper, No need of taking advantage of writing onto the ground. All computations were carried out mentally. When one of the interviewers remarked that it was a pity that Fuller had not the kind of education that was equal his genius, Thomas replied and said, "It is best I got no learning, for many learned men be great fools." Details of these records are found from a text, Historia Mathematica, on pages 141 to 151. The material was compiled by John Fauville and Paulus Guez, and it bears the title African Slave and Calculating Prodigy, the Bisymmetry of the Death of Thomas Fuller. Part text of this material in PDF format is found on the internet, and I have provided a link to the PDF in the video description. This section, this one, is one of the most exciting parts of the passages on Thomas Fuller. It relates to what happened immediately after Fuller gave his solution to the second proposition. It reads, "One of the gentlemen who employed himself with his pen in making these calculations told him he was wrong, and that the sum was not so great as he had said, upon which the old man hastily replied, 'Top, massa, you forget the leap year.' On adding the number of seconds of the leap years, the amount of the war in both their sums agreed exactly." That's quite interesting, isn't it? Someone who had neither a pen nor a paper, correcting him who had every kind of advantage. I first came across the information related to Thomas Fuller sometime around 2016, and by late 2017, I managed to discover an explanation as to his arithmetic algorithms. But it is now 6 years since I made the discovery, and people are bound to ask as to why I did not announce the discovery then in 2017. The main reason is that Fuller's calculations were not reliant upon the mathematics algorithms that are currently dominating our modern-day schools and colleges. They were dependent upon a separate school of mathematics thinking, the African School of Mathematics. The African, in brackets, Egyptian School of Mathematics is different from the European, in brackets, Babylonian School of Mathematics. And this difference was first recorded by Herodotus of Halicarnassus way back around 450 BCE. It is the Greco-Babylonian school of mathematics that evolved into becoming the European school of mathematics. And when Europe invaded the rest of the world, they carried together with them this Babylonian school of mathematics and forcibly imposed it upon the conquered peoples. This is how it ended up becoming the international and only recognized school of mathematics thinking. And limited attention was paid to the African school of mathematics and a bulk lot of the mathematics contributions from other parts of the world. Thomas Fuller's calculations were not based upon a single algorithm that a researcher can discover and present in a single academic paper. They were reliant upon a different mathematics philosophy that demands a completely different mathematics syllabus. This separate school of mathematics is the one we are referring to as the African School of Mathematics. The best approach to try and explain the mathematics ideas of Thomas Fuller is to disclose the mathematics world in which his arithmetic algorithms are founded, and whoever gains an understanding of this school of mathematical thinking will by no means fail to explain full-as arithmetic calculations. The two schools of mathematics differ in approach, yet both can be used successively to resolve common mathematics propositions. Let us give a simple example to illustrate what we mean when we say that these schools are different in their approach to the same mathematics content. Suppose that one is required to carry out the addition of these four numbers with each number having 4 digits. How does one go about it? First, let us add clarity to the numbers by placing the numbers with the same positional value in a distinct column. Let's go ahead and add the vertical lines to separate the columns. Now we have units, tens, hundreds, thousands, positional values. It should be remembered that these numbers are in base 10. Each column to the left is 10 times greater than the positional value to its immediate right. A number like 5,000 is equivalent to 50,100. 700 is identical to 70 tens, and likewise 8 tens is the same as 80 units. This underlined number is 3,400. It is correct to call it 3,400. Alternatively, it can also be called 340 tens. With this in mind, let's try and manage the addition of these numbers. We begin with 5 plus 3, that's 8, plus 1, that's 9, plus 4, that's 13, and we are having 13,000 in our memory. 13,000 is equivalent to 130, 100, plus 7, 137, plus 4, 141, plus 6, 147, plus 9, 156, and we keep 15600 in our memory. 15600 is equivalent to 1560 tens, plus 8, 1568, plus 1, 1569, plus 0, 1569, plus 4, 1573. And in our memory, we keep 1573 tens, and 1573 tens is equivalent to 15730 units, plus 6, 15736, plus 2, 15738, plus 9, 15747, plus 5, 15752. And we are done. This is our solution. And in this approach, that's how African mathematics is dealt with. That's how Thomas Fuller would manage his calculations. It is done. No pen, no paper. Simple, fast, and no hassles of carry digits. Now, there are 2 guidelines on how to manage mental arithmetic computations. First, all number operations are carried out beginning with most significant columns. If we use modern-day number orientations, calculations are done from left to right. Second, digits call in a number should not be restrictive but should be interchangeable. As you heard me call the digits, the call involves bases and units, and since we are using base 10, the call includes tens and units only. Instead of calling the number like 15,752, it should be called 15,752, and the number words for hundreds, thousands, and higher positional values are excluded. In actual fact, they introduce unnecessary inconvenience. Let's bring one another into remembrance. Let us look a little bit into well-known mathematics. Have you ever tried to think about the way number operations are carried out? By number operations, we mean addition, subtraction, multiplication, and division. Have you not realized that the first three, addition, subtraction, and multiplication, are done from right to left, but with the division is the other way around. It is carried out from left to right. This anomaly is enough to trigger an investigation. Number operations should be carried out beginning from the same positional side. You mark this anomaly. We shall address it along the way. To iron out on information related to the African School of Mathematics, we shall go through over 200 video lessons following the list of topics that does follow. You take effort and subscribe to this channel to support this transformation in the way in which mathematics should be taught. Thank you, and meet you in video number 2, where we will continue with part 2 of the introduction.